All right, so this is our basic function definitions. Anything of this that's not familiar to us? We feel pretty comfortable. Domain, range, what is a function? All right, so a lot of what we're practicing today is what you see below. Writing an interval notation versus inequality notation. So a lot of us coming up from Algebra 2, Algebra 1, we're comfortable with these inequalities that we see here on the left. The x is between 3 and 5 with the less than or equal to symbols or just the plain less than. We in this class and going up to calculus are going to be using interval notation, which rather than inequality signs uses parentheses and brackets in order to write different ranges of x and y values. So for something like the inequality you see to the left there, x is greater than negative or greater than 3 and less than or equal to 5, you would set up your interval to say that x is between 3 and 5. The brackets basically correspond to the less than or equal to or greater than or equal to, where the parentheses correspond to the less than and greater than signs. On a graph, brackets will correspond to closed dots, where parentheses correspond to open dots or infinities. So what would be the difference between the interval notation I just wrote and the one that you would write below? Same numbers, just use what? Parentheses. Now, the inequality on the left, the third one down, the x is greater than or equal to 5, you have to think about it as in terms of if it's greater than 5, where does it go out to? It goes, out to infinity. So what am I going to write on the left? What are we going to start with? Bracket and 5, and then it's going to go out to infinity. And infinities, we always use parentheses. Okay, very, very similar on the next one, only you would start with a parentheses 5 out to infinity. You can mix and match brackets and parentheses like you see in this last one. So if x is just purely greater than 3, you would start with parentheses 3 out to 5, but 5 would have a bracket. Any issues with the interval? Did we do interval notation last year? Yeah, so that's familiar to us. That's been something they've worked more and more on. So some years this is brand new when I teach it, and other years it's familiar, which is great. We will also be using function notation where we have f of x is equal to something. Remember that f of x is the same thing as y equals. So f of x is y equals, g of x is y equals, h of x is y equals. It's just a different way to write your y so that you can show an input with it rather than just showing y. All right, so on the back, we'll get started with, or we'll finish up our vocabulary, and then we'll get started with some big old graphs on the next page. When you are stating domain and range, remember domain is from the left to the right, where range is from the bottom to the top. So if I look at this particular graph, my domain, I'm going all the way to the left here, and I'm seeing this arrow, which means that that graph keeps going and going and going to the left. So where does my domain start on the left? Negative infinity, right? My domain starts negative infinity, and if I follow it all the way to the right, I hit a closed dot at what x value? 7. So I would do 7 with a bracket. All right, same thing with range, but you do have to be careful on this. Think about for range, bottom to top, what is going to be the lowest y value, or where does the graph stop on the bottom? I hear -4 and I hear negative infinity.
-4.
Which one is it? Negative infinity. Why? This. They tricked you with that. That arrow wasn't sitting below the -4, but it doesn't mean it doesn't keep going. So because that branch keeps going down, my range still starts at negative infinity. Bring it along. Where does it stop up on the y-axis? Okay, at 4 with a bracket. Good. I swear I did my attendance. Oh my gosh. I am one of these people, aren't I? We were all here. I'm going to submit it. Sorry. One of these days, I'm actually going to do this. And I'll start this. Okay, we're here. Thank you. Okay, to tell if this is a function, we need to see if it passes the vertical line test. So remember, the vertical line test just says you either actually draw vertical lines or think about drawing vertical lines everywhere. What tells us if it is not a function? If that any of those vertical lines would ever touch 2 points on the graph. So each of my vertical lines only goes through 1 point on the graph every time I draw one. Therefore, is this a function? Yes. Now, do we remember talking about one-to-one functions at all? No? Okay. So a function is a function if it passes the vertical line test. Each x value has exactly one y value. In a one-to-one function, it goes one step further, where a function is defined as a set where each x value has only one y value. A one-to-one function is a function in which each y value has exactly one x value. So no x value or y value can be used twice. Because it is already defined as a function, it means that it has already passed the vertical line test. It can't be one-to-one if it's not a function already. So a function has to pass something called the horizontal line test. Works the same as the vertical line test. So if we went through the previous graph we said passed the vertical line test, so it was a function. Let's look up at that graph again. Would this graph pass the horizontal line test? No, because I could draw a horizontal line, let's just say here, and go through 3 different points. So that's not considered a one-to-one function because that y value of -1 is used in 3 different places on my graph. And that's not okay for a one-to-one function. All right. X-intercepts, y-intercepts, hopefully we already know how to find those. I'm not talking about those. Other than the fact that x-intercepts can also be called roots or solutions. Okay. You know how to find x and y-intercepts off a graph. Decreasing and increasing and constant. I'm not writing out the technical definition for these. Increasing is when your function is going up from left to right. Decreasing is when it's going down from left to right, and constant is when it is flat. If I could draw that a little bit better, that'd be good. But it is always left to right, so be careful of that. Now, let's put all that together on a graph on the next page. I would like for you on your own, instead of me doing all of this, I want you to do any of those questions that you can using the graph that is given. A lot of us are pretty familiar with some of this, so it should be somewhat easy. If you don't know what one of them means or how to find one of them, like if you don't remember doing increasing and decreasing, just leave it and we'll talk about it. So given the top 6 that we mostly remember, what does this notation mean, this f of 3? What question is that asking me? If our normal notation is f of x, what are they giving me? The x. They're saying if x is 3, what is y? So how do I find that? I go to x equals 3 on my graph, go to my graph, and estimate the y value of that point. So what would be f of 3? -2. Now that is paired with question 5 here. 4 is saying when x is 3, what is y? What is 5 saying? When y equals 3, what is x? Okay. Okay, and these could have more than one answer if it is not one-to-one, which this one is not. So if I'm looking at 3, there's actually going to be 2 answers to this. And sometimes you may want to draw this in yourself so that you don't miss these. If I draw in y equals 3, there are 2 different places that intersects. Right there and right there. So what are my answers for 5? And 6. All right, so using what we just talked about, what is question 6 asking us then? When x is 0, what is y? Also the same as the y-intercept, -3. Question 7 is then asking us the reverse. So question 7 is asking us what? When y equals 0, what is x? So what are my answers for 7? I don't have that there right now, but okay, we've got -2. What else? 4 and 8. Good. I'm going to come back to question 8 in just a second. Okay? Let us talk just increasing, decreasing, constant real quick. So increasing, decreasing, and constant, we're going to write in intervals, just like the domain. So the only thing that uses y values for the intervals is the range. Everything else uses x values. I'm going to erase what I have on my graph here so we can just look at a clean graph. Increasing is where the graph is going up from left to right. So the way I see it in this graph, I have 3 different sections of my graph where it changes directions. Where would be the increasing interval? It's kind of this middle section right here, right? That part of the graph, if I'm going from left to right, is going up. And if you actually have to take your finger on your paper and trace, your graph is going up as you go from left to right, from there to there. So we're writing that in terms of x intervals. So what does that section start at? What x value? 1.1, because that's this right here, the minimum. So I start at 1.1, and my x interval stops at, where does the top of the hill happen there? Right here at 6. When we are doing increasing, decreasing, and constant, we are always going to use parentheses. Okay, and here is why. It's kind of the physics concept of at the very bottom of the hill or at the very top of the hill for a very small second, it's not increasing or decreasing. Okay, it changes direction. So we're not going to use the brackets because it would say at 1.1 at the very, very bottom, it's also already increasing. And so we're not saying that. We're going to say that it starts increasing right after 1.1 and then stops right at 6, before 6. So decreasing, how many sections do we have that are decreasing? 2. I have this left section from here to here, and I have this section from here to here. Again, we're always going to use parentheses, and we're always going to use the x values. So the decreasing is going to start at what x value? -4. And it's going to stop decreasing right at the bottom of that hill. What number? 1.1. The second section is going to be from where to where? Okay. Okay, and what do we use when we have 2 sections of the graph put together as one answer? Do we remember this? The U. Big U. It's not like super necessary as long as you have both sections, but now constant we said is flat parts of the graph. Do we have any flat parts? No. So I would just say none for constant. Now we have 2 questions on this that we did not answer yet. It's question 8 and question 15. 15 is similar to question 5 or 7. So what is 15 asking me?
Y is negative 2.
Y is negative 2. What is x? So again, I typically draw a line here. Y is negative 2 to make sure that I know all of the places where y is negative 2. So for question 15, what are my answers? Negative 1, positive 3, and 9. Okay? Because it also is that final dot over there on the right. If it was an open dot, you would not count it, but we do in this case. So question 15 was f of x equals negative 2. Our answers are negative 1, 3, and 9. Final question that we haven't looked at yet was 8. 8, for some reason, is always the trickiest question. It asks us, where is f of x greater than 0? What is f of x? Y, right? So that's asking me where on this graph are my y values greater than 0? Well, where is y equals 0? In the middle, right here. So if I kind of cut the graph off at 0, what parts of my graph are the y values greater than 0? Above the pink line, right? So that's this section. And where else? Okay, the other section that's above. So I'm going to have two sections to write for this, and it does say just greater than, not equal to. So that tells me whether I'm going to use parentheses or brackets in this. So that first section, again, we're still going to use our x values for this. That first section goes from an x value of what? Negative 4 to an x value of what? Negative 2. And I'm going to use a parentheses because it just says greater than. So if I use a bracket, that's the equal to, and we're not including that. That second section, the little hill, starts at an x value of what? 4 and goes to an x value of 8. Any questions about all of those questions? So some of this is familiar. Have we done the increasing, decreasing constant before? That's new to us? Okay. All right, we'll practice more with that. We are actually almost done, believe it or not. So, on the next page, what I would like for you to do, now that we've talked through one type of each question on this, is to work through this graph and do your best to do the newer ones as well. Okay? If you want to talk to the people around you to do this, we'll take about 5 minutes to do what we can. You're welcome to talk to someone else and work with them. So the notation we're using for our domain basically says I start my domain off at negative infinity. The first place we have a problem is negative 3. The parentheses on both sides basically just say we're skipping over only the x value of negative 3 and continuing on. So that's the easiest way to write that. The range, we don't have to skip any values because that open dot there is taken care of by the bottom of this U takes care of that open dot over there. So you don't have to skip for your range. Real quick to talk about the increasing interval. It is increasing on that section from negative 4 up to 2, but you can't actually say that it's increasing at negative 3 because there's nothing there. So we skipped over negative 3, continued out to 2, and then we skipped and started, that's a 7, not a 6, excuse me. That's a y value of, or an x value of 7, continuing out to infinity. So then the decreasing interval is just that middle section there that would start at 2 and go to 7. And we do have a constant section here. That is the flat section to the left. So the left part would have started at negative infinity. Here you could make the argument that when I stop at negative 4, You could make that a bracket or a parentheses because it is constant at the point that it changes from one direction to another. So I would accept either brackets or parentheses there on the constant one only. It's just a good habit to be in right now to get all of your intervals in parentheses for increasing, decreasing, and constant. Okay? Question?
On number 21,
Yes.
how is it not just 1? Because it's saying if x equals 0, then y equals...
Ooh, I flipped those, didn't I? Thank you. I flipped 22 and 21. When x equals 0, y is 1. When y equals 0, it's negative 1, 4, and 8. Sorry about that. The two that I've missed now are 23 and 30. F of 2 is going to be the closed dot, which is 3. And then 23 is similar to the previous page where we did that section where f of x is greater than 0. This one is f of x is less than or equal to 0. This time it's equal to, so I can use brackets. So for 23, the section of the graph that is below that line is from here to here and this little section down here. Now, that first section does have that open dot in it. So my answer for 23 is going to end up being negative infinity to negative 3, skipping over negative 3, and going to negative 1 with a bracket because it is equal to. And then there's a third section that I'm just going to have to squeeze in here from 4 to 8. Woo. And real quick, we've just talked about this, but give the intervals where this function is increasing and decreasing. So take a minute, practice increasing, decreasing one more time, and we're going to talk about how that relates to maximums and minimums. All right, so with our increasing and decreasing, any issues first? We increase from the arrow going to negative infinity all the way to the top there, and from the bottom all the way out. We decrease in this middle section. Notice that basically when you look at these increasing and decreasing intervals, if you fit them together, that negative 2 to 3 kind of fits in that middle section that you're missing and you're increasing. So if you fit it all together, it becomes the entire graph from negative infinity to infinity. Where a function stops increasing and switches to decreasing, right here, that's going to be your maximum. Where a function stops decreasing and switches to increasing, right here at the bottom, that's going to be your minimum. So that's really those definitions that you see right below. Since f of x is increasing to the left and decreasing to the right, we have a maximum at negative 2. The maximum value at negative 2 is the y value. So at negative 2, what is the y value? 4. So that's that last blank down here that I just cut off. So the maximum location is negative 2. The maximum value is 4. The same type of thing works for decreasing and minimums. Since f of x is decreasing to the left and increasing to the right, it has a minimum at 3. The minimum value at 3 is the y value at that point. So at 3, what's the y value? 0. Now, you don't really need to think about increasing and decreasing and where they switch to tell maximums and minimums, right? In something like the graph that we see below, which is where we're finishing, you would just be able to look at this graph and say, all right, there's a maximum at the top of the hill on both of these, and there's a minimum at the bottom of the hill in the middle here. And that's all I really need to know, right? So in particular, A, when it asks at what values does it have a maximum, what is it asking for, the X or the Y? At what values?
X.
The X. So my answer to A is that there is a maximum at -7 and +7. What are the maxima, or what is the maximum value? That is asking for the Y value. So at both of those maximums, what's the Y value? 3. We're not going to worry about justifying.
Wait, so if the two like ridges are at different heights,
They would still both be considered a maximum because of the definition of changing from increasing to decreasing. Okay? We're talking in here about what in calculus is called local max and min. Because really, if I asked you for the actual minimum on this graph, if it continues down, the real minimum is -infinity, right? Because it just keeps going. Local just means this definition of where it changes from increasing to decreasing. So yes, if one of those was at a different height, they would still both be considered maximum. So at what value do we have a minimum? X equals 0. What is the minimum value? That's your Y value. In this case, that is what? -4. Okay. And last, just quick practice with domain and range. All the way to the left means my domain starts where? -infinity. All the way to the right means my domain goes out to where? Infinity. The bird is back, guys. You remember the bird from last year?
Oh, I do.
He would literally live in front of my room, Napier's, and McKinley's the whole way. He would come back and forth. He ran into it a couple times. Ms. Napier debated killing it. She really didn't like it. Range on this one, if it goes all the way to the bottom, where does my range start? -infinity, and then stops at what Y value? 3 with a bracket. All right, I am done with notes.